Just 1 through 11. That was it. 1 through 11.
Let's see. These are my notes. I know I started in class, and I'm supposed to finish all my stuff this year.
That's what I'd like to hope.
I did more than half.
You switch notebooks, bro.
Yeah, like.
All right, Wes, then what's your question?
A lot of
Specifically,
Specific.
Like
number
a lot of science.
number 5. So you have 3 different circles, various radii, and you have tangents to everything. So you got a point P, and then you have 1, 2, 3. I'm just going to roughly draw this 1, 2, and this one's kind of a little bit bigger, like that.
Oh yeah.
And then you have that, which is 8.2. You have that, which apparently goes to point B. You have that, which apparently goes to point C. And lastly, you have this that goes to point D. It says in the diagram before, in the diagram, find PD. So basically from here to here. Well, boy, this does look complicated. We just go back to corollary. It's not corollary 1, it's just one corollary. Corollary said this: if you have a point to any circle and there are 2 tangents, and this side is 10, guess what that side is? All right, so watch the magic.
It's 8.2.
All of these are tangents. So if this is 8.2,
8.2.
well, if that's 8.2, even though it's a different circle, and if that's 8.2, that's it. There was no math involved.
It just looked like there was.
Now, I mean, this causes people problem because as they look at the diagram, like, well, how is that even possible? It goes back to that corollary.
They don't look the same size.
And they don't look the same size, but they end up being the same size.
I thought it was something to do because it said.
Why do I have 2 pages of homework? Did I get turn in homework?
All right, probably because I didn't put you as having a 0 for the last one. All right, what else?
Why did I get
All right,
too?
what else?
That was homework before.
Danny, which one did you struggle on?
How late have I
Okay,
homework?
Seth, hush, so I can do this. All right, let's take a look at number 4. Number 4 says the following. You're supposed to use this picture. You have a circle. You have a center. The center is O. You have a tangent at the very bottom, T. That's a radius. You have a point off to the side, which is J. You have a line that goes back to O, and you're told at that point right there is K. So number 4 says if JK is 9, so just from here to here, that's 9. KO is 8. I'll put it at the bottom here, is 8. How long is JT? We go back to theorem, is it 9.1? 9.1 says what if you have a tangent? It's 9 degrees, therefore, Danny, what kind of triangle do we have? We have a right triangle. Okay. Right triangle. Right triangle. Well, here's the other thing now. This is the part you probably got lost on. Look at OK and OT. What are both OK and OT? OK and OT are both, they're radii. There's no math here. If OK is 8, then how long is OT? There's no math. I kind of thought maybe it might be dealing with a right triangle, but in this case, it doesn't. Yeah, that was once again one of those ones where you got to give it, it's not algebra. And algebra, if you don't know what to do, you're done. You can give up immediately. Like, I don't know how to solve that, so you give up. In geometry, you got to give it some time and look at it. Yeah, maybe at first you don't realize what's going on, but as soon as I point out, Wes gave me the eye roll, right? Like, this is the geometry eye roll. Like, how come I couldn't see that? I see it now, but why didn't I see it when I was doing it? That's what geometry is all about. It's a logic thing. Next year, when we get back to algebra, you can get back to that. Yep, I didn't study that. I don't know what to do. I'm just going to tell you, in geometry, most of the time you will know what to do, but you got to have the perseverance to go for our, one of our core values here at school. But you got to have some perseverance in geometry. I can't tell you how many times that I've done a geometry problem where I've stared at it for hours, if not days. And when it's finally explained to me, I say, boy, am I a dumb.
But
Dummy,
you're finding
Dumb bits.
JT.
Right.
Dumb bits is a great one to say.
Say again?
Dumb
You're
bits.
finding JT, not OT.
Okay, so now use Pythagorean theorem.
Yeah.
So we use the Pythagorean theorem, that's 17, that's 8. So whatever 17 squared minus 64 is, take the square root of that and you're done. Book says it's 225, so that would be 15. All right. Ready? All right, here we go. Number 1 is 8. Number 2, 2 root 34. 2 root 34. From now on, as you go into algebra 2 and into pre-calculus, calculus, generally speaking, unless they say give me an approximate answer, if you ever get anything with a square root in it, you leave it with a square root. You don't grab your calculator and write a decimal. Number 3 is 12. Number 4 is 15. We did 5, was 8.2. Number 6 is 12. Number 7 is a proof. I will look at that.
Number 8, 9, and 10 both have 4, 3, and 3 parts. So
Yeah. So 8A is 72. 72. B is 1818. C is 144. And D is yes. Number 9A is a square. Number 9B is 5 root 2. Number 10A is OS and SP. B is OP and OS. C is 12 and 12 root 5. And the last one, number 11, is a proof. And it has something to do with similar
I
triangles.
just didn't want to do 8.
All right. Enough of that. Yeah.
11 there.
I know you didn't try. I mean, I didn't know straight up. You just gave up. You have to try. You have to try. Saying this, I look at it, I don't know what's going on, is not enough. Try means that you look at it. When you don't understand it, you don't immediately give up. You flip back to what we just covered, and you see what are the corollaries, what are the theorems, what are the techniques that we just learned. You can't just immediately give up. Wes, did I give you one or no?
No.
Coming at you. Almost. All right.
I still have
If there was a name for this chapter that wasn't its normal name, which is basically circles, this would be called the definition chapter. We've already had a lot of definitions. We get more today.
Yeah.
All right. I'll collect homework here in a second.
what's the date?
Today's the first.
Oh, no.
All right, so we're gonna do 9.3 and 9.4, and then we kind of reach our level of, whoa, we've covered way too much. We're gonna take a break Wednesday. We're gonna do a review sheet. Now this class, there's a couple of you in here. I gotta make this statement. Hey, if you want me to put the F in the grade book right now, I can. If you don't try, don't waste my time. Just tell me, hey, Mr. C, I'm not gonna try. Just put the F in. That would save me a whole lot of effort. If you want to try, I will grade your quiz. If you want to do the review and not mess around, I will let you take the quiz. If I don't think you've worked, I'm not going to give you the quiz. I'm just going to put an F in the grade book. I want you to take the quiz, the review seriously. The review will be exactly like the quiz. So some of you did really poorly on the test. Not many of you, but some of you did. This is your chance to start digging yourself out of the hole you just dug with your F, right? So take the review seriously. Take today seriously. Hey, here's the nice thing. Yes, it's going to be a whole bunch of new vocabulary. It's weird. Today is really simple. I mean, it's really simple. There's nothing complicated about today if you pay attention. Nothing. We will get two. It's really just one skill, but I'll call it two. Right? So we're going to learn a couple theorems. It's actually a postulate. We're going to get a skill out of it, and it's stupid simple if you pay attention, right? No, I'm not calling you stupid if you don't pay attention, but I'm just saying it's that simple. It's literally a 1+1 type problem if you pay attention today. But there's a lot of new vocabulary. You got to wrap your head around it. We'll take that review. We'll take the quiz on Thursday. We'll move on. The rest of this is a hard chapter. There's a lot of skills. It's confusing at times, okay? But I will promise you, on the level of if you understand it, how easy the test is, it's a simple test, but you got to understand all the skills involved. All right, homework tonight. Hey, 1 through 11 again.
Dude, that's like 3 days in a row.
Well, that's because it's where A ends. Section A. It probably was 3 in a row, but 1 through 11 is the, I will just say this, there is a table involved, an ugly table. We will look at it at the end of class, just to make sure that we're okay with how to do the table.
Is it too late to throw in the towel?
No, this is, like I said, today is a really simple class.
Yo.
Seth, you were my
I like throwing
consistently A student until the last test.
Yeah. Dude,
All right, and that was only because you missed a couple days.
Yeah.
But
this week,
different story.
different story.
All right, and Ethan, I expect you get another B.
missing.
I was a B. 77.
B where?
Oh, it was a 77? Well, I'm saying this one's gonna be a B.
Oh, okay, cool.
All right, arcs and central angles. Arcs and central, 2 brand new things you've never seen, never done before. Boy, are they easy. Really easy.
Howdy, diddly-doo.
All right.
How are you?
So it's another one of those lessons with lots and lots of definitions again. All right. So lots and lots and lots of definitions. Get over it. All right, the first one, look at the board. Hey, I got a circle. There's the center. Hey, Chandler.
Yes.
Circle, center. I'm going to make an angle that comes out of that center point right there. I'm going to make an angle, right? So I mean, you need 2 rays to make an angle. There's my 2 rays. Notice what I just constructed: a circle, a center, and an angle. That angle, and you saw this on the NWEA test. You will not see this in this book, but I always use that symbol. That just means X. Like, why don't you use an X? Because in geometry, I don't know, we're special. So we don't want to use an algebra thing. We want to use a variable just for ourselves. So we use the Greek letter TH. It's not a T and an H, it's the sound in Greek, right? So that's called theta. That's the letter theta in Greek, and it's just X. But whenever you see theta, it's you know you're dealing with geometry. You see an X, it could be algebra, it could be geometry. If you see theta, 100% you're dealing with geometry problem. Okay, that angle right there. Where did this angle come from? The center. So you want to know what we name that angle? We literally call it the center angle.
Wait.
Except it's not the center angle. We're going to call it the central angle.
Okay, this is the most straightforward geometry ever been.
I told you this is a ridiculously easy class
Like,
today.
usually it's like, oh, it's in the center, but we're gonna call it the
Right. We're going to call it the straight angle or something like that, right?
Yeah.
All right. So central angle. This is the angle that's formed inside of a circle where the vertex is the center. You're like, how could I screw that up? Oh, you're going to screw this up because we get different kinds that have the same look, so to speak, that deal with circles and deal with angles, yet they're not central angles. They get different names. Okay, but not today. That's coming up in this chapter. Okay, so central angle, an angle formed where the vertex is at the center of a circle. Cool, right? No big deal. So that's a central angle. Are we okay? All right, is that a central angle? If that point right there is the center of the circle. Yeah, that's a central angle. Now, I can make an angle anywhere I want on a circle, right? Here's an angle, right? This is later on in our chapter. Guess what this one is called? It's not a, that's a good guess, right? This is not a central angle. You see where the vertex is? The vertex is on the circle, not a central angle, okay? Where's the vertex now? But the rays intersect the circle. These two we get later in the chapter.
Oh, fun.
But these are not,
Central angle.
they are not central angles.
All we need to know.
That's all you need to know right now. That's a central angle, these are not. And this is, we get formulas for this, and we get formulas for each one of these. These are all different. All 3 of these are different. And you're like, when you see today's formula, you're going to say, I could never screw that up. You know how you screw it up? It's because you mix up this formula with this formula with this formula. It's easy to screw up. Central angle is the easiest one. It's not even a formula. Yet I'll have kids, when I say, what's the central angle? They'll give me this one. Okay? All right. We good? All right, more please.
Oh,
All right, so look at what I just drew. What did I just draw?
That's a circle.
A circle, and I drew a
Minor.
central angle. Do you see the central angle? I just didn't put theta there. What do you notice? It's in red. About the central angle.
Why is this?
It cuts off a portion of the circle. Do you see that? That portion now is in red.
And that makes fragment down.
All right. Oh, great. All right. So the red portion is what we're looking at. Okay. You probably heard this word before. You just didn't know what it truly meant. In geometry, we call this particular construction, the red part, somebody,
Minor.
we call it an arc. Right? That portion right there, the red portion, we call it an arc. And the definition of an arc is part of a circle. I said today was easy, but it's new vocabulary words.
Why isn't it bendy line?
Because it's part of a circle. So an arc is part of a circle.
Okay.
How much of a circle? Well, we get 3 of these. We can't leave it at this. We got to make it more complicated.
Of course.
There are 3 of these. There's also a mathematical symbol for arc. Microsoft doesn't allow me to use it. So
Really?
if you look at all my math stuff and before, you get this thing in Microsoft called an equation editor. It gives me every symbol under the world, every single one that exists in the math world, except for arcs. I have no idea why they left it off. Hey, boys. So you're going to see me use a symbol for it that isn't the symbol, but it's close. In the book, they give you the actual symbol. I bet you can take a guess what the symbol is. It's an arc.
That's a
Right.
dang arc.
I'm going to use something in math we call a tent, right?
What?
All right, but it's the closest I can come to an arc. All right,
That's great.
arcs come in 3 flavors. Now stay
Ah.
with me. This is where it comes. Stay with me. This is where it becomes slightly confusing. Not much, but slightly confusing. All right, in box 3 or your book of truth, I don't care either one. We haven't come to anything that I would say has to be in the book of truth, right? I will tell you what thing needs to go in the book of truth when we get there. Okay, types of arc, there's 3 of them. If the part of the circle, the arc, is less than 180 degrees, we call that a
Baby arc.
baby arc, except they're going to call it a minor arc. Okay, a minor arc, right? You see the symbol right here? This is not the arc symbol, but it's close. An arc is literally an arc. You'll see it in your book tonight for homework. Okay, we call this a minor arc. A minor arc is when the central angle is less than 180 degrees. That means 0 all the way up to 180, not including 0, not including 180. We call it a minor arc. That's flavor number 1, minor arc. Hey, there's the name of that minor arc, YZ. Makes sense, right? Could we also call this minor arc ZY? Yes or no?
Yeah.
Yeah, we could. How many letters did I use? I used 2 letters. All minor arcs will use 2 letters. This is called foreshadowing. Yeah, I don't have the sound effect now. All right, minor arcs get 2 letters. Whichever 2 letters, they must be the endpoints of the arc, obviously. Okay? What in the world am I going to show you now?
Reverse arc. It's
Notice it's got the same central angle. Chandler's yelling out answers, but for the rest of you, what do you think? If this is a minor arc, this is a minor arc.
Daddy arc.
The red looks exactly the same.
the offender.
If that's a minor arc, then this one must be,
A major arc.
write that down.
Thank you, Danny.
If a minor arc has 2 letters, do you see the problem if a major arc had 2 letters? If I called this major arc YZ, do you see how you could confuse that with the minor arc?
Yeah.
If you just use the 2 endpoints, Y and Z, there would be no difference between a major and a minor arc. Therefore, the minor arc we leave as 2 letters, and the major arc gets, you got to have some intermediary point between the 2 endpoints of a major arc That's why a major arc gets 3 letters. All major arcs get 3 letters. A major arc, if this is, look up here, if this is, I don't know, 60 degrees, then we're really talking here, the central angle is the outside here. That's 300 degrees. From here to here, 300 degrees. Can you see that? If this was 60, then this would be 300. So the central angle we're talking about is the angle that goes from here all the way to here, 300 degrees. So major arcs, that's where the central angle is larger than 180 degrees. Minor arc, smaller. Major arc, greater than. I said 3 flavors, so what's the third flavor?
Medium arc.
What number did I leave off? If minor arcs are less than 180, major arcs are greater than 180, what number did I leave off?
180.
I left off, no, less than 180, not less than or equal to. Greater than 180, I left off
180.
exactly 180. So what do you call an arc that's 180 degrees?
You have it figured out.
It would be that picture right there. Any one of those, our book decides to call it a semicircle.
Because it's not a full circle.
Not a full circle, it's half. Okay, semicircle. This is, and now it's a major arc, right? Got to have 3 letters, right? How come I couldn't call this YZ? Because you wouldn't know which direction to go. Look up here. If I called this semicircle YZ, you don't know whether I'm talking about this direction or this direction. Can you see that? So semicircles and major arcs always get 3 letters. Minor arcs get 2. You could put 3 for minor arcs, but no one ever does. All right, who's lost? Did I say today was easy? It's easy, but it's new vocabulary. Oh, by the way, you can screw it up if you don't know the difference between a major, a minor, and a semi, right? Semi get 3, major get 3, minor arcs get 2 letters. Once again, that's not the arc symbol, but that's as close as I could get to it. Right. All right, we good? All right, central angle is exactly 180 degrees. All right, so it turns out that there is a relationship between the central angle and the arc, major, minor, semi, whatever. There is a relationship between the central angle and the arc. Take a guess what that relationship is. They are both equal to each other. You're on fire today, Stephen. All right. So if that's theta and that's 60 degrees, then this distance from here to here, we're talking about angular distance, is also 60 degrees, right? It's 1/6 of the circle, okay? So the relationship between the central angle and the arc created by the central angle is that those two are equal. They are congruent, or it should say congruent, they are equal to each other, okay? So central angle equals the arc. Central angle equals the arc. Central angle equals the arc. It's an easy relationship. It's got a really bad name. Do you want to know what they call it, though? No, that would be a good one. You would remember that one, right? Write this one in your book of truth. Here's your first one that has to go in your book of truth. Write this, Danny. You're going to write that here in a second, but it needs to go in your book of truth, okay? The central angle equals the arc, but we don't call it the arc. We call it the measure of the arc. And you want to know why that's a bad word? What does it imply that you're doing? And for most of us, when we think about measuring, we think about a ruler. So if I say the measure of the arc, some of you are thinking about how long that arc is, literally how long in inches or centimeters. You also want to know why it's confusing? Because next section, we will measure it with a ruler. And we'll give it a different name. And it sounds just like that. One is going to be called the measure of the arc. The other one's going to be called the distance of the arc. Arc distance. And I'm just going to tell you, for high school students, everyone gets those two confused. I'll ask you to give me the arc distance or the measure of the arc, and you'll flip-flop those two terms. The measure of the arc is measured in degrees. The arc distance is measured in, I don't know, inches, centimeters, whatever the units are. But this says the measure of the arc, it's measured in degrees and it's equal to the central angle. There's no math involved for this one. The other two flavors, you have math involved, but that's not today's class. If you get this wrong tonight for homework, you were not paying attention. There is no, Danny, there's no math involved. They're going to give you this as 50. They're going to say, what's the measure of the arc? You put 50 degrees and you're done. That's it. Nothing complicated. As soon as we get the class on arc distance, then we start having problems because it'll ask both arc measure and arc distance. And it's a different formula. And they're not equal. All right. Hey, they will try to make it more complicated. It's not. Matt, what's in red on the second one there? What's in red on the second one there? A major or a minor arc? Okay. So they're trying to get you to do a little bit of thinking. If y to z is 50, then what's the major arc? How did you do that? So it's a self-obvious thing to most students, but maybe not to all, that if they give you the minor arc, you can easily calculate the major arc simply by subtracting from 360. So if you need to also put this in your book of truth, put this in your book of truth. That the major arc is always equal to the 360 minus the minor arc. Conversely, and I don't have this written, the minor arc, if they give the major arc, would be what? If they give you the major arc, how do you find the minor arc? Okay, it's the same thing, except I just didn't choose to write that. At this point, usually every kid gets this. Connor, yes, no? Is that an obvious thing? So I can give you either the major or the minor, you can calculate one or the other. You subtract it from 360. However, if I give you the central angle and ask you to calculate the major and the minor, it's not much thinking going involved, but you got to remember the relationship between the arc measure, or the measure of the arc, and the arc is that they are equal together. Central angle and measure of the arc are equal. Hey, if you have this picture, is there any calculation involved? So what's the measure of that arc? 180. Pretty simple, right? No math involved there. All right. Next definition, you ready? What do we got? A semicircle, right? How are we going to find yx? Even easier than that, because you told me that the red was a. So how are we going to find yx?
Wait a second. We need numbers. We have no numbers.
Yes, we do. What is the red?
180 minus y.
So how big is yx?
Whatever 180 minus dx.
Whatever 180 minus yx was, right? How would you find xz? Same idea, right? Either you know what yx is or you don't. If you don't, then you notice that it's a semicircle, 180 minus whatever that is. All right. Now, what was postulate 3? Not angle measure. What's postulate 3? Or is it postulate 4? No, I'm sorry. Postulate 4. What's postulate 4? Postulate 4, and if you can't find that, find postulate 2. What was postulate 2? Guess what this one's going to be? No.
Oh my God.
Postulate 2 is 7.
If I told you what yx is, and I told you what xz is, could you calculate yz? So guess what this one's going to be called? Postulate 2 is called the ruler postulate, and postulate 4 was called the protractor postulate. This is postulate, I don't know what number we're on, I think it's 16. This one is going to be called the adjacent arc. Okay. Adjacent arcs. are arcs that have one point in common. Do you see the point they have in common? What point do they have in common? They have x in common. Notice yx, xz. And together they make this, well, semicircle. Could be a major, could be a minor. But if you have two adjacent arcs, those arcs have to share one, not two. If they show two, they're overlapping. They show more than two, really overlapping. But if they have one point in common, we call them adjacent arcs. Why did I ask you about postulate 2 and postulate 4? Because if we have adjacent segments or we have adjacent angles, what can you do with that? You have adjacent segments. If you have adjacent angles, you can. And if we have adjacent arcs, you can add them together. This is going to be postulate. We good? This is going to be postulate 16. It's called the arc addition postulate. So we had the segment addition, we had the angle addition, now we have the arc addition postulate. And it simply says if you have two adjacent arcs, well, the sum of them together equals the larger arc. So if I add up yx and xz, I get the larger one. That's all it says. Right? If you need to write down a formula, well, there it is.
Dude, why do they have us doing stupid clocks?
Clocks are absolutely that's the.
I know. It's just like, for number 8, not number 8, but for number 7, they just want us to divide 260 by 12 to find each angle of each hour. I feel like that would just be the quick, easy way to do it. Because every angle.
How many hours are there on a clock? How many degrees are there in a circle?
260.
Therefore, each hour is how many degrees?
I don't know that.
That's what they're asking you to do.
I know, that's what I'm saying. I'm yeah, it's simple.
Oh my God, a calculator is so. All right, we good with postulate number 16. I don't know if it's the last postulate in the book, but it might be. All right, remember we don't prove postulates. All right, here's a duh example. Who wants the duh example?
I'll take it.
All right, Ethan wants the duh example. Ethan, how big is ABC?
No.
Oh, Lord.
200.
200, yes.
Sorry.
All right, who wants a non-duh example?
Me. I'll take another one.
All right,
No.
Cadence, how big is AC?
On.
How big is AC?
Do you subtract 90 from
How big is AC?
I don't know.
Well, what do we know here on the problem?
ABC is 200.
So how much of the circle is that not include?
100. 160.
Okay, so you just did it. All right. So the duh one is, well, how big is AC? The non-duh, or sorry, ABC, and the non-duh is AC, but they're still pretty standard. Danny, you catch that? How big is ABC, Danny? What do you get? So how big is AC? Now you said ABC is 200. Now how big is AC? If from there to there, I've lost my pen. It's not going to be around the same size. Here it is. If from here to here is 200 degrees, how big is from here to here? Because 200 plus 100 equals, because 200 plus you're claiming 100 equals, and that's how many degrees in a circle, right?
No.
How many degrees in a circle, Nate? So if this is 200, then AC is. Okay, tell me what would I have to do mathematically, I'll do it for you. Tell me what to do mathematically, though. How many degrees in a circle? Well, how big is this? That's from here to here, so what's left? You did it. Good job. All right, that's why I knew you could do it. Okay, so there's a dot and non-dot. All right, last definition. Oh, we're just tore through this today. All right, write this down. This is the weird one that you got to do a little bit of thinking to. They're called congruent arcs. Now, we've dealt with congruency before. Be careful what it says in the definition. It's critical that you understand what's going on here. It says arcs in the same circle or what? Or another congruent circle. Guess what it doesn't say? Arcs in any circle. It's not saying that. It's saying either arcs in the same circle or arcs in congruent circles. Remember, circles are congruent if the radii are equal. Therefore, we define congruent arcs as arcs in the same circle or congruent circles that have equal measurements. And remember, we're talking about arc measure here, not arc distance. If you need a picture, here's the picture. Do you see that circle P there?
Oh, I love peace.
Okay. How big is AB? How big is CD? Therefore, CD and AB are no, they are they're congruent. Are added together, sure, 160. So these are arcs in the same circle that have the same measurement, 80 degrees. But I could also have another circle. If I have another circle, before I say they're congruent arcs, you paying attention? Before I say that this 80 is equal to this 80, guess what I have to do? I have to make sure that the radius, and this one is also 6. If it's not 6, it doesn't matter that they're both 80. They're not congruent. They're equal, but they're not congruent. I wish that this would be the example I would show you when we started back chapter 1, the difference between equality and congruence. Here's a perfect example. These are congruent, right? I'll show you another one where they're equal, but they're not congruent here in a second. We okay with this picture? Let me show you ones that are equal, but not congruent. All right. Remember, they are congruent because the two circles are congruent. Okay. So I could say that this piece, AB, is congruent to EF. Why? Because the circles are congruent. I mean, clearly 80 is equal to 80. The big but here is that what happens if the circles are not congruent? How big is the arc? How big is the arc? Do you agree that 80 equals 80?
Yes.
100%. But notice the radii are not the same. Therefore, even though their measures are equal, they are not congruent. Not congruent.
So wait, does the congruency not then rely on the measurement, but instead the distance?
It's this congruency is this idea of it's the same shape, comma, and the same size.
Okay.
So same shape, 80 degrees, not the same size.
So if we found the same distance for two arcs, we then assume that they have
No. Because was a couple sections ahead, right? Let's say we measure this and it's equal to 12 inches.
Yeah.
Well, there's 12 inches on this one. It could be the whole darn circle.
Okay. Oh.
This is arc distance. We haven't got to that yet. All right. Okay, so that's the basic idea of not congruent arcs. Certainly have the same measure, equal measures, but not congruent. If they are congruent, right, you're either talking about congruent circles or the same circle, right? It's the same circle as long as the measurements are equal, good to go. But if you're talking about two different circles, step one is we got to make sure that the radii are equal. If the radii are equal, then you can make a comparison. If the radii are not equal, you can't say anything. They can easily have the same measurement, but they're not congruent. We okay? All right. Write this down. This is a very, very, very simple theorem, right? Book of truth. All right. This is, I believe, the only biconditional one in the entire book. Biconditional means it goes both ways. That's why there's an if and only if. In the same circle or incongruent circles, two arcs are congruent if and only if their central angles are congruent. Two arcs are congruent if and only, or that means both ways. That means central angles are congruent if the arcs are congruent, and the opposite. Arcs are congruent if central angles are congruent. That's what the if and only if means. It means it goes both ways. Hypothesis, conclusion, conclusion, hypothesis. You can say it both ways. This is not much going on here with this theorem. We don't get any skill from it. All we basically get is the fact that things are congruent if either their central angles are congruent in the same circle or congruent circles, or if the arcs are congruent and the circles are congruent or to the same circle, then the central angles are congruent. With the exception of some very minor math, mostly either subtracting from 360 or subtracting from 180 if it's a semicircle, there isn't much math today. But it's the idea of arc and arc measure. Not arc distance, but arc measure. I wish we had different names, arc measure, arc distance, but we don't. You're not going to find this confusing until we get to arc distance, which is tomorrow. Tomorrow arc distance. Not yet. All right, because I know it's always confusing, we got about 6 minutes left. We are going to open our books and look at the tables. All right, number 10 and 11. Open up your books to number, to page, where are we at? Page 342. Get your books open to 342. Trying to head this off before people say, I tried those tables and I got confused. Our book loves tables.
First question. I got.
All right, Matt, pick anything on number 10. Let me draw the circle first. Here's the circle. O is the center. You got a diameter. You got a point C here, A and B, and A connects to C, and C connects to O. And we have any measurements? No, we got an angle 1 and angle 2. That's it. Give me any column that you want to do. The first column. The first column. The columns look like this. We have measure of arc CB, M measured. And then we got measure of angle 1, measure of angle 2. Measure of angle 1, measure of angle 2. And we're given on this one that the measure of CB is 60. Do you see that? Yeah. Okay, if I were to label that CB, we're talking from here to here. That arc measure is 60 degrees. The first theorem we got tells me if this is 60 degrees, then not A, 1 is 60. Yes? What do you notice about AB? Where does it go through? So ACB is a, how many degrees in a semicircle? You just found that this is 60, so AC would be, which is, no, it's not your brain. 120, there's angle 2, so therefore angle 2 is. Questions? That one wasn't hard.
Do they get harder than that? What about
Pick one, pick a column, and then the rest you have for homework. Pick column.
the last one?
Last one. What are we given? We're given that measure of angle 2 is x. That's it. Okay, so it's just the reverse process. If 2 is x, let me erase the 60. If 2 is x, then what's AC? Then what's CB? And that would be angle 1, so 180 minus x. You get that? And what's CB? It's the same thing. Remember, central angle equals arc measure. That was easy.
Wait, really? That's what you do? That's the answer?
Well, it's not a very satisfying answer, but yeah.
Yeah, no. So I
Do the fourth row.
Say again?
Do the fourth row.
No, you gotta have some that you do. I'm not gonna do them all.
I did them all. I just.
I'll talk to you, student advisor. I'll help you that.
But
I'm not to
Are you
class.
gonna do
All right.
11?
Yeah, we'll do a couple more.
Yeah, the fourth
Are we
row,
good?
11.
All right.
I want to do the fourth row.
All right. So the other picture is, of course, they couldn't give you a nice simple one. They're going to give you a very complicated one. You still have the diameter, and is it still O? It is. And this is still A. This is still B. And then we have a C up here, and we have a D right here. And that connects to that. That connects to that. Something else? Yep. Oh. Okay. We got that ugly thing. We got, read it off to me, channel. Measure of arc CD.
Yeah, and then mark.
Measure of
CD.
BD.
Arc BD.
BD.
And then measure of angle COD.
C angle COD.
And then measure of angle CAD.
CAD. All right, pick a column.
The fourth row.
Yeah, let's do it an easier one so we don't cause them problems.
But I don't understand.
Then
Well, I know, we'll do the fourth one, so I don't want that to be the first one on this one I do.
Okay, then do the first row.
First row, what are we given?
Measure of arc CB is 70.
We're given that 70.
And mark or measure of arc BD is
30. Okay. So CB is 70. BD is 30. And we need to find COD. All right, I'm going to put O up here. COD would be this whole darn thing. That's pretty easy. So that's, that was easy. CAD, so from here to here is 100. CAD, therefore, would be, if from here to here is 100, how did you do that? Okay.
Oh,
that makes more sense.
yeah, that makes more sense.
I'm just sitting here like, wait a minute.
Yes?
How on earth did I get that and stuff?
Well, what is the conversation we've had about geometry from the start? And what was the conversation I had to start when you said I tried it and I gave up? I said, he's been trying it for, I mean, it's the end of class. He's been trying it for 45 minutes and he hasn't gotten it. You tried it in 10 seconds and you got it. You tell me why you got it and you did. I don't know. If I could solve that, I could tell. But it's the perseverance and getting to the, oh, I get it. You know, that's what you got to not give up on.
Would it still be 100 because it's the angle of CAD,
Yeah, that's what I was thinking. Because
not the, so
if you
it's
get
still,
rid of
It doesn't go to the center.
Measure of CAD. Wait, did I do this wrong? I did this wrong. Never mind.
You did. I knew you did. I was,
Yeah,
I was like, there's
God.
no way that's right.
okay.
How is that 100 then? I'm confused.
You think of what we were talking about earlier. I didn't even read the problem right. Okay, if they had asked what is the measure of arc CAD, yeah, 260, but they didn't. They said what is angle CAD. Check this out. Notice that they both go to the same point, so therefore if one's 100, the other one's 100.
dang it.
Got it.
How come you didn't get that the first time?
I guess myself.
No, I got that. I don't
Yeah,
get
I got
the
that.
fourth row.
The fourth row. All right, we have time to do the fourth row.
I'll stay.
All right, fourth rows.
Yeah,
We're just
'cause I
told
get
that
a
it's what,
negative,
60,
then I try to do
52,
Yeah,
right?
you can't get negative, but I'm getting a negative.
60, 52, right? Did I got this right?
Yeah.
All right, so CB is 60. CAD is 52. What?
Yeah.
Yeah, I know.
So did we do the other ones wrong?
No, we did it perfectly right. Okay, CB. Oh, no, this is 60 right here. Okay, we're fine. That's 60.
No, the whole thing. Oh, yeah.
From here to here is 60.
Yeah.
And then it's saying,
The angle of
CAD.
CAD is 52.
oh, we did the other one wrong too. You don't get plus one. We still haven't
That's
solved the
why
other
I
one.
wasn't. That's what weirded me out.
All right, let's go back to the previous one.
I don't know what to erase. but
That's 100. So that makes that 40, right?
Yes.
Okay. And we're trying to find this angle right here. Well, we can find this from here to here. We can find that.
Isn't that a transversal? No, it's not. What are you talking
Well,
about?
we do know that from there to there is 260. That means from here to here is 260.
Well,
Is it cut in half? It's not. Oh, if that's 60, then this is 120. If that's 40, then that's 140. There's our 260. I'm thinking that we're going to get it with angle of a triangle, maybe? Nope. If that's 120, this is 120. How am I going to get that angle right there? How am I going to get that angle right there? Oh, I'm going to give this one some thought.
okay.
Because I don't know how.
I can see the answer, but I don't want to.
And you forgot to collect them.
I did forget to collect homework. Put it over there next to the printer on your way out. I have an answer by student advisor. Finally, first time this year that I've actually gotten a question that's going to require me to give it some thought.
No, there was one earlier.
Which
It
one?
was super easy. We just couldn't figure it out.
Oh, okay. No, but I meant there's one that I can't like answer on the spot. That's
Yeah,
why I like.
You had to come give it to the supervisor.
Oh, one earlier this year?
Yeah.
All right, so second time this year. All right, e-learners, do you have any questions? Send me a chat or an email.